exercise is to actually use method from the math class and not as much writing your own method like we did in previous exercise. So I'm finished here with the boilerplate code, okay, and we are going to look at the description of the textbooks. This textbook informs us that we need to generate 10 random number between 0 and 1000, compute their mean and compute their deviation using appropriate method from the math class. So if I need to generate random number, first step, initialize pseudo random numbers generator. How do we do this? Random, let's call it rnd equal new random parenthesis. If I use the class random, I need to import it, java.util.random. And then I can start generating my 10 numbers. Counter control loop, that's a pretty clear cut here. I equal 1, I lesser equal to 10, I plus plus. Body of my loop will consist in generating pseudo random number. Yep. Okay, how do I do that? rnd.next int. And if I want it between 0 and 1000, I'm going to do 1001. I'm at the point where I can test something here, so I'm going to add some code that is not requested of me. Okay, system.out.println the value for number n. And as I was writing that, I realized that I didn't store my random number in a variable, so I'm going to add this variable on the fly. So now I have a program that can display 10 random number on the screen. Well, before to go any further, let's go to Conqueror and let's debug this program. E521.java. Okay, no syntax error, that's a good start. E521. Let me see what we have here. We have, I should have displayed the value of I as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 random numbers, none of which is out of range. So this is a good hint that our program is performing appropriately. So my point, of course, is not to display only those 10 numbers on the screen. Let's have a look to what I have to do. I have to compute the mean and the deviation of these numbers. So I'm going to have to store the sum of those numbers to compute the mean, which I'm going to divide by the total number of those random numbers. And then I'm going to have to store the square sum of this element. Okay, if I look at the equation, these are the values that I'm going to have to keep. So we're going to need a couple more variables. First step, the count variable is going to tell us how many number we have. Right now, I hard-coded this value here. I'm going to use it also to divide in my final formula, so I don't want to use any more a value that is just typed in my code. I want a constant. So final int count equal 10. That's going to make my life easier if suddenly I have to, instead of doing 10 number, do 20 of them. I don't have to modify the code, I just have to modify this line. Okay, so I modify my loop already accordingly. Now next, well, I need to keep track of the sum of all those numbers. So I'm going to store this in a double variable, which I'm going to call sum, and which I'm going to initialize to 0. Then I need to keep track of the square sum. So I'm going to appropriately call it square sum, initialize to 0 as well. And I'm going to add a little bit of commenting. Sum of all numbers. Even if it's obvious for me right now, square sum of all numbers. Actually, sum of the square of all numbers would be a lot clearer to whoever comes next to work at this program. And this here is number of random numbers to generate the series. Okay, so we spend a little bit of time commenting. That's a good thing. We have our loop. Now I'm going to take it one piece at a time. The first piece I'm going to tackle is I'm going to add all of those numbers to my sum. So sum, at each iteration, sum equal, I'm going to use a plus equal assignment here, number. Just to make sure. At this point, I could remove this println. Actually, I could keep that println and instead, after the loop, display something like system.out.println. Sum is, and I'm going to display the value of the variable sum. Okay, I'm going to do the same with the square sum. Square sum at each iteration is going to be plus equal, and this time I'm going to use the power method of the class math. I'm going to take number and I'm going to square it. And I could display here similarly system.out.println square sum is followed by the value of square sum. And something is red, which means I forgot a double quote. Here we go. Let's try to save. Compile. We have a little bit of work to do at the syntactical level here. So first error, variable number is unknown. Let's go back to the code. Variable number, yes, number is called n in our program, just as I used here. So we're going to save again. Back to Conqueror. Let's try to compile again. What we have now is, I'm going always to the first one. Same error, number is not known. So let's go back to the code because I just think we just fixed that. So we're going to save again, make sure that the file is saved, and maybe there was a little delay necessary before to compile. So I'm going to clear my screen, and I'm going to compile again just to make sure. And this time everything is working. All right. Now, Java, exercise 521. These are my numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them, the sum, and their square sum. And at that point, you need to take the n calculator, add all of those things together to make sure that they work, and then make the square of each element and make sure it's the result displayed by your program. So you have to make a test by hand pretty much. So I'm going to let you do that, and meanwhile I'm going to go back to the code so you can pause this video and make sure it's working. I'm going to go back to the code here, and we are going to add the next feature. The next feature is actually, once we computed the sum, once we computed the square sum during the loop, then we are capable outside of the loop to work on computing the deviation and the mean value. So computing mean value. The mean value is going to be the easy one. Okay, we're going to declare a variable mean of type double, and we're going to simply divide sum by the value of count, and we are done. Computing standard deviation. This one is going to require a little bit more work, so let's start with a variable deviation of type double that we declare. We use the method sqrt of the math class, square root, and we are going to take our square sum, subtract the sum, times sum divided by count divided by count minus 1. So this is straight off the textbook, okay? And then system.out.println here, mean is plus the content of the variable mean. System.out.println std dev is deviation. Okay, save again, Conqueror. Let's get rid first of our syntactical problems. None at the present time. Let's run the code. Sum and square sum. So what's going on here? Let's see. Let me go back. I think we have still this little problem here of delay. No, actually I didn't save the code properly. You can see here that it's modified. So I'm going to wait for the code to pop back up. Save it. Alright, this time it's done properly. Go back to Conqueror. Java C. Java. And same thing here. Okay, we have the mean value, we have the standard deviation, and we need to just like pretty much double check these with a hand calculator. Okay, so let's pop up our bit of calculator here, and let's start with, well, let's start with the obvious. Okay, the sum. Let me like erase it here. Reset the calculator. Okay, 914 plus 100 plus 542 plus 852 plus 818 plus 335 plus 51 plus 838 plus 969 plus 72. Oops, 72. Okay, our sum is correct. Next thing was the mean. Well, since we have 10 numbers, the mean is obviously correct as well. The next thing to check is the square sum. So this one is going to be even less pleasing. 914 plus 100 square plus 542 square plus 852 square plus, where am I? 818 square plus 335 square. So this is a very error-prone process. In fact, I had to do it twice while I pause the video to get it right. The only reason for which I introduce it in the video is to show you that yes, this is boring, yes, this is error-prone, and yes, nobody wants to do it. However, you have to do it to make sure that your program is working. And I think I introduced just a bug because I was trying to multitask and talk at the same time. We'll see with the final result. Yes, I introduced a bug while I was talking, so I will just shut up and redo this, paying proper attention. 914 square. Okay, there we go. So the square sum is correct, and I will let you do the standard deviation because at this point all the components of the last equation are correct. So we just have to take, well, let's do it together, the square sum, which is what I have here, minus, it's always annoying to do it with a calculator as opposed to something that has an algebraic representation. We are going to do the sum squared. Our sum is going to be 42, 95, 403, which we are going to square, and which we are going to divide by n, which is 10. Okay, so we have the square sum minus sum squared divided by n, and we are going to divide again by n minus 1, which is 9. And we are going to reset this because obviously I made an error here. So let's go at it again. So our square sum is 429543 minus our sum 5491 times 5491 divided by 10. All of this divided by 9. We're going to do a square root of this. That is assuming that I can locate the square root on this prehistoric thing. Okay, well, we're going to do it differently. Okay, 377.16, well, we came up to a result. So like I said, yeah, this is not going to teach you to program in Java. This is just going to teach you maybe to use the calculator of Windows, which anyway is something I would not wish to anybody, but it's going to mainly teach you that you have to spend sometimes as much time testing program, testing code, than actually developing it. And even if that seems fake on a simple example like this one, you will see when you have to develop real code in a real project that this is actually a statement that is correct. So here's our full version of the code, and we are pretty much done with this exercise.